So I wanted to talk today about ingesting billions of records a month without breaking a sweat. I was actually looking at even doing a demo today of trying to do that in like 10 minutes, not over a month. And it turned out it was going to cost me like $4,000. So I decided maybe next time. If I ask really nicely, sometimes I can get credits from the cloud providers to do those things. But 10 minutes before the talk is not a good time to make that decision. Right? So with IOPipe, what we do is we observe Lambda workloads. We do not sample. We collect everything. One of the main reasons we do that is because one of our main value adds is structured logs, and we don't want to throw away, important information that you need for debugging. And honestly, as much as I've heard, some other companies claim that it's like extremely, cost inefficient to do that, we do that, and we collect everything. We collect billions of records a month. We do that in real time. We do that with unpredictable spikes across the regions. We do that on a startup budget, and we do it resiliently. So we need to do that right without breaking a sweat. Mostly breaking a sweat mostly refers to budget, right? Because that's the biggest way in which we sweat as a startup. And we solve that we actually use Kinesis, but you can also use Kafka. There's no movie called Kinesis that I could find, so I had to make a dub. That may be familiar to you for anybody who's ever used Kinesis. But actually, I really love Kinesis. There are some issues we've talked about maybe actually switching over to Kafka for a number of reasons. Some really great opportunities, features for retries and backoffs and things that aren't in Kinesis, and it's made certain things more difficult. However, it's also allowed us to be creative in solving some of the solutions. This is just a really high-level architecture of how IOPipe works. A customer Lambda executes on the top left. That goes into instances that are running on Elastic Beanstalk. We chose EC2 for this because we need to be really low latency and low cost. API Gateway was an option. However, it's quite expensive, which is actually the reason that doing that 10-minute billion invocation demo would have cost me $4,000. That would just have been API Gateway costs. So we decided to use Elastic Beanstalk and EC2 instead. Especially when we first created this architecture, there were restrictions in API Gateway in terms of performance. API Gateway, just to process a request, takes, I believe, 7 milliseconds. That's fairly high. We chose not to use Route 53 for geolocation because it adds latency. We instead decided to, we know which region a user's Lambda is running in, so we just deployed EC2 instances into every single region, and you just, use DNS, right? US West 2 dot, metrics.iopipe.com or whatever, right? And that geolocates things because we already know where you are. We can just run things in the same data center. That feeds into Kinesis. We send individual records into Kinesis. We don't use bulk records because we are processing these in near real time as possible. Those Lambdas execute and feed data into various sources, right? And that's effectively our kind of an ETL step. And then we have our APIs, which use GraphQL on the bottom, using API Gateway, Lambda, et cetera, that pulls from various sources. This talk primarily today is going to be about the Elastic Beanstalk, Kinesis, and Lambda, and mostly the Kinesis part, right? But you can't really talk about Kinesis here without talking a little bit about those EC2 instances and those Lambdas. Mostly the Lambda side, given that this is a serverless conference and not an EC2 conference. This is actually collateral from AWS on Kinesis. So Kinesis becomes basically a pipe which is a provision pipe. So you need to allocate n number of shards, which are pre-allocated which define your maximum capacity for requests, which defines both read and write performance, which I'll get to in a little bit. That can have unlimited writers as long as you don't exceed your maximum rate of writes or amount of data that you're writing. And you can have as many readers as you have shards. So especially with Lambda. So every shard will be associated with a single function concurrency. So like you deploy one function, and if you have 10 shards, you have 10 concurrent Lambdas running at a time at maximum. And of course, those Lambda functions can write to whatever service that you want them to write to. In our case, the service is on the previous page. So the way that we do this, right? So the Elasticsearch, I'm sorry, not Elasticsearch. The Elastic Beanstalk EC2 instances, they simply forward HTTP payloads to Kinesis as events. Again, there's a low latency requirement, individual put records, and we're actually testing migrating this to Fargate. This is a really good use case for Fargate because we want to be able to scale this and manage bursty loads without having. So one of the great things about Kinesis is that those Lambdas, every shard is basically associated with a Lambda concurrency, but it's burstable, right? You don't have to have as many Lambdas running as you have shards necessarily. However, we do need to have the maximum capacity for Kinesis ingestion on the EC2 side. So moving that to Fargate would have some advantages for us in terms of burstability and lowering our costs. One of our big questions is if we can still maintain the low latency aspect that we currently have with Fargate. So that's currently being evaluated and probably deployed within the next month or two if everything looks good. The Kinesis stream has very few knobs, but you must provision those shards, right? They are statically provisioned. They impact the data rates and records per second, and you have a retention period, which is 24 hours, configurable to 7 days. So with that retention period, it allows you to do things like, for instance, our databases, we do daily snapshots. If we had corruption of tables or indexes, and they were not in those snapshots because they were within the last 24 hours, we could simply replay the stream. And we could do that with actually a separate writer. So we can continue having the writers and Lambda functions that we have deployed already. There, we can just deploy a new function that does backfill. And we have actually done that before. It's not anything we've had to do recently, thank goodness, because we were able to, we've been able to build up, resilient architectures and processes and runbooks. But in the beginning of IOPipe, we had to do it a couple times when we were still, getting our feet wet with operating this at scale. And record processing, right? So on the far right side of this is, that's a bad way of phrasing. So on the right side of the Kinesis stream, we're reading those records that's processed by Lambdas. You create a Lambda function, you configure the Kinesis trigger, you specify the batches, how many records are sent to each function, and then you can set the iterator, right? So normally you would set this probably latest, but in the case of, like I described earlier, of doing backfill, you could set this to a specific timestamp, or you could set this, there's a number of options here that you could set it to, right? And this, so I'm going to talk a little bit about tape systems in this talk. But one thing that I feel is that Kinesis is not serverless; it's serverless because it operates like tape. It's a streaming platform like your traditional tape systems. You have to process everything in real time. There's mechanisms for retries and time-based correction and all those things that are available inside of tape is available inside of Kinesis. But because it's provisioned, I personally don't consider it truly serverless or fully serverless but it's definitely somewhere in between. Let's see here. I had a reason for this slide. Oh, so one of the biggest challenges with tape was the ability to read that data onto other medium, right? That ability to process that data has increased significantly. So on the left-hand side here, we have the internals of a VCR. And I went through this photo, and I went through some photos of internals of VCRs, actually. And I realized, like, most VCRs didn't have surface-mounted chips. They might have had 1 or 2 ICs, integrated circuits, maximum, right? They're primarily analog systems using, like, large capacitors, and they didn't have a lot of things like ICs in them. But now we have things like Lambda, right? And you can get basically an S3 in a box with Lambda from Amazon in this little snowball machine. But tape's biggest challenge, there's this idea, which I've heard, and I don't know where this has come from, this idea that tape is slow. Because tape is extremely fast. And in fact, it's the biggest challenge with tape, right? Because you couldn't read the data off of the tape and process it fast enough to not have buffer underruns on the tape device. Because the tape would make sure that you process all the data as it comes off. And if you can't process the data fast enough, then the tape stops, and then it rewinds, and it plays, and it rewinds. It's called shoe shining. And one of the amazing things about Lambda is that it's unlimited compute, right? So you can do things like run something that's equivalent, using Kinesis, equivalent of a massive tape system without the complexities of engineering around tape. Because the reason tape was expensive was you needed to have giant RAID arrays in order to buffer the data, because the data actually came off the tape so quickly. Right, because Lambda is that boundless sink for real-time data processing. Kinesis shifts records into provisioned shards, and those shard counts affect the Lambda invocation rate. So as you create those provisioned shards, that basically becomes individual buckets you can send the data into, that then batches that data and sends them into Lambdas, and that sets basically your concurrency rate and your invocation rates. Each shard is associated with thus the throughput of the writes, the number of invocations, and the amount of data that you can maximum transfer. So one shard is a maximum of 1 megabits per second, or megabytes per second, writing into the stream. You can read at 2 megabytes per second, which is really only useful if you're catching up on the stream. If, let's say, you had a partial iterators had gone up, which I'll talk about in a little bit. It's 1,000 records per second maximum, or 1,000 invocations per second. Now, realistically, you cannot do 1 megabyte per second and 1,000 records per second. I guess you could if the records are very... So it's tricky, because each of those invocations Lambda invocations can only take 6 megabytes per invocation. So you have to kind of decide if you're going to have throughput, data throughput, or the frequency of requests, like number of records, the rate. So you have to, when you deploy the Lambda, you have to then consider the batch size. That trade-off between data throughput and records per second. One shard is up to 5 reads per second. Normally it's 1 read per second, ideally, but there are situations where you might get more than one. Reads, and there's a 2 megabyte per second tier for reading, which is a maximum of 5 readers. But again, those writes are still locked to the 1 megabyte per second. It's primarily a system for catching up. If whatever your sink that you're writing into falls behind and your iterators back up, then you can read more. So just for some comparisons of data rates, right? SATA 3 is 600 megabytes per second. LTO, which is tape, 750 megabytes per second. But if you have 1,000 shards on Lambda or on Kinesis, you can do a gigabyte per second, right? You can go faster than SATA 3. You can go faster than tape with just 30 seconds of initialization time on AWS, and it's pretty cheap. It's like 0.015 cents per shard hour. So you can do the math on that. It comes out to like, I don't know, like $10 an hour or something, which isn't terribly bad considering what you're getting, right? If you want to, you could actually have, you could provision Kinesis streams that are as fast as DDR3 memory. But you also have transactions per second. And this is actually a friend of mine in Pink Flamingos. So transactions per second, 1,000 shards is faster than an SSD can write, right? In terms of the number of records and IOPS per second. That gives you a lot of power to really build amazing systems. But it's also equivalent, so 1,000 shards, right? And a million transfers per second turns into, because that's a million transfers per second, that is equivalent to 1,000 CPUs running concurrently, right? And all you have to do is just provision this on Kinesis. You can just go in there, type in the numbers. By default, it actually locks you to 500, by the way. So you can't just go to it right now and do 1,000. You have to call AWS to get 1,000. But you can do half of that. You can get the SSD speeds, which is 500 shards, and you can do that by just going to AWS console and then paying your bill at the end of the month, which won't be a very large bill, thankfully. It may be a large bill if you're invoking all those Lambdas and you're putting it all through API Gateway, in which case, honestly, your biggest bill is going to be API Gateway or your EC2 to get the data into it. Scaling shards, again, provision capacity. Let's see. When you scale those shards, when you need more shards, you can at most double the shard count. And you can at most have the shard count if you need to scale down. So you do want to, this is not a thing that is just burstable and scalable ad hoc, right? You want to plan ahead. You want to have extra capacity, which also introduces problems. Scaling up will introduce hotspots because the data, when you write it into a shard, it stays there. When you add more shards, the data is still in the shards that's there. So then if you don't have scheduling in your writers, you're going to have those now maybe not permanent hotspots, but until there's an opportunity to catch up on the stream and lower the utilization of those shards, certain shards will be warm. And you can increase your limits. You do need to make sure that your Lambda concurrency limit matches or exceeds your shard count. This is something that I've seen catch people up. It's not a big deal, especially when you're under 1,000 shards, because your concurrency limit will be 1,000 by default. But if you decide for some reason to drop that or manually configure your concurrency limit, you could find yourself not actually able to process and consume those shards because it's a 1-to-1 ratio. And if your concurrency limit is, set to let's say 10, and you have 20 shards, they literally can't run. Right? And once passed to a Lambda, if an invocation fails, it will retry. So the idea is there's an iterator. So you're basically reading. So each shard is almost like its own stream or tape device on its own. So each of them has its own read iterator that determines where in a stream you are. And that makes sure that records are never processed more than once, in theory, or that you're not traveling through time. You're traveling through time, but only forward, right? Ideally, we travel forward in time. We hope. Now, there are situations where things can happen more than once. Because Lambda, it guarantees at least once execution. So even though Kinesis may only make sure that it gets processed only one time, Lambda can basically do double evokes and accidentally run 2 invocations for the same data simultaneously. So when you do things like write into databases, you might want to use things like on conflict do nothing and making sure that you're basically inserting data and ignoring duplicates. So 1 billion records, because that was the title of this talk, is one, batched into batches of 1,000, which is kind of idealistic. It doesn't happen. But if that happened, it would be 1 million Lambda invocations. In reality, ingesting 1 billion records is going to be more than 1 million Lambda invocations because you're not going to have 100% utilization of those shards. You need to have extra capacity planned out. Right? And this also assumes Lambda invocation durations are under 1 second. 100% utilization is undesirable on Kinesis. This is another reason why I don't consider Kinesis itself to be particularly serverless. Because, for instance, Lambda, it's always 100% utilization. You have 1,000 concurrent Lambdas, you have 100% utilization of each of those Lambdas. Kinesis, not quite the same, right? You probably want to over-provision if you ever are going to expect to have bursts. That means over-provisioning, decreased utilization per shard, more invocations, more shards, fewer records per batch that is sent into those Lambdas. There are some solutions for this. I don't think I have them in my deck, but you can basically do shard scheduling. So you could schedule to make sure that records get into the right places. And basically, if you want to, you could fill up shards. And as those shards get full, go to the next shard. Or you could do combined cohorts so that if you're writing to databases on the back end, that you maximize shard performance of those back end databases that you're writing to. I do have a slide on it. It's coming up next. So duration versus shards. You do need to double the number of shards per second of the average function duration. So this all assumes that you have Kinesis can run, say, 1 invocation per shard per second. But if your Lambda takes over a second, suddenly you're going to start having iterator backups, right? So you need to have as many shards, really as per second of compute that you have, not necessarily just say, oh, I need to have concurrency of X, Y, and Z, and just create that number of shards. You need to have as many shards. So at every second that you go over 1 second, you need to increase the size of that. I guess it's not really double. It's really a multiple of the number of seconds. That was inaccurate. Shard scheduling. I just talked about it. So we have 5 minutes. I was going to do a demo. I may not have a lot of time for it, but I'll try and show a couple things. This is the iterator age of a production system from a couple weeks ago, where we had an iterator. The iterator age increased pretty significantly, right? And you can see that what we do is we do keep things at a place where, if I scale through here, you'll see that generally the iterator age is about 0. And sometimes it spikes up on you'll have 1 shard that gets 100 milliseconds of latency on ingestion until something bad happens. And this is where the database, or one of the databases we were writing to, we exceeded its thread pool, and we were unable to, the queue backed up internally inside of the database. And then it started rejecting requests, which then caused Lambdas to retry. The Kinesis iterator backed up, and it kind of bubbled up here into an alarm. I can look at, this is actually our production writer that was occurring, and this was midnight on a Sunday night. So it was a pretty low traffic period. We were only having 100,000 invocations per second. And this is only in one region, by the way. This is only in US West 2. We have something like this in every region. And it gets busier when it's not a Sunday night. But you can see that the invocations dropped, right? Because we are getting errors, and we weren't able to write to the database. Reads were not working. It was a little bit of a mess. And let's see here. Durations also increased significantly during that period, right? Because writes to the database were delaying, so everything backed up. Let's see here. Unfortunately, this function is not deeply instrumented because it's writing to the database. It's a really bad place to be adding lots of instrumentation. Oh, this is an example of one of those writes, which we have a 30-second duration maximum there. You can see that it was retried. So if I actually click the retry, this one failed. And eventually, right, Kinesis makes sure that eventually we have a invocation that works and submits the data correctly. So this one only took 24 milliseconds, and it was successful. And that's what Kinesis does, right? It makes sure that eventually we're going to have a successful invocation. And one of the great things in IOPipe is you can see, OK, well, this failed. Here's the one that actually worked. And you can dig into things like custom metrics. We can see how many invocations. We actually automatically grab in auto instrument and get how many records. We're only actually writing 2 records here. Although in our backend database, there were like 14 that were written because there's some expansion there of the data. And let's see. This is actually the cause of what happened. We had a weekly cron job that was supposed to spread out things into an SQS stream. So basically, it was supposed to schedule a bunch of emails to happen over like an hour. And they all happen simultaneously. So then you can do things like, go in here to GraphQL and see which ones. So GraphQL talks to our databases, and we can see which ones, say, for instance, took long. And then start doing some dives into what the hell happened. Anyway, I'm out of time to really debug this any further with you live. But thank you very much, and I hope you gained something out of it.